Список составляется покупки чего-то. Ничего не будет.
Я уже отдал. Beers. Oh, cool. Oh, welkom wel.
Dobry.
Nocy. Nocy, Piemonte. Okay, let's go. I have an interesting object for today.
Right now assignments development on WhatsApp.
Cool.
I don't know, there are some agencies who do some freelancers who are on these Indians in Latvia group and all.
Yeah. I hate this. One interesting object. Cut AVB. Not ideal picture. Wait, stupid. No, it's not good. Come. What? I can get. Okay. Okay, I got something. Some kind of compromise solution. I can get my instruments. But why I need this screen? And what's going on here? Who are you?
Well,
UI, it's my toy. It's a rheostat with motor. What's this?
It's constantly changing.
120 volts. I have a rheostat from classical electrotechnic theory, yeah? But it's motor driven. Not by hand, by... I can show it. 1 second. Not to break anything. I have a motor driving it. I have a load of 3 bulbs. Nothing special. And I have something more interesting. Signal from here comes to first this blue box. It's converter from voltage to current. Proportional current goes to ADC device. Goes here. So it's a 2-channel ADC. What's in ADC? Analog to digital converter. It's converted into a form of integer, how to say, in simple words, it's a voltmeter. Yeah, producing voltage or current in relative values. It produces integer from 0 to 32,000, something like this, proportional to input current. It has 2 channels. I have ADC1 and where can I put it? And ADC2. They all 2 channels are connected to this device. It's a microprocessor, microcontroller. So first ADC gives me this voltage in proportional values, in integer. And second one, I have, how to say, source of E0, ground, with this trim, I can change set point. You see, voltage set point, measured voltage. Microcontroller, my microprocessor, drives these 2 relays, up or down. Oh, left, right. And up, down. And they are driving what? Motor. With my block of relays. Actually, we do see what? Closed loop system. I said 150 volts. Watch what happens. Oh. Yeah, they are 0. I reduce load. Regulator goes down. I increase load. Oh. See what happens with voltage. Reduce load. It's a voltage regulator, voltage stabilizer. I change load, this closed loop system operates in such way that delta U, voltage difference between set point, I'm changing set point for one, it's approximately 100 volts. And this should be multiplied by 2. And voltage follows. Reduce load. Difference is near 0. I need a dead zone because this resistance cannot be changed absolutely continuously. It's contains of wire, and there always be what? Like this one, you can see. There always will be a step. Because you connect to one wire and then to the next and to the next, and there is a space between them. I can set 200 volts. Should stop somewhere here. Load increased, load increased, load increased. Okay, maybe I choose something. 150. Fine. Come here. Maybe I. Get it right. Get something. Okay, what I first video. Okay, where am I? Camera don't work. The screen is too bright. White screen is too bright. It's definitely this way to make it last. Program visible. Okay. Now, tiny experiment. What kind of experiment? I've changed what before. I've changed load. Let's say for something. Oh, 60 watts. Nice. Appeared. Show the instrument closer. What I will do now, I will change supply voltage. At this moment, we have a constant voltage. What will happen when I change supply voltage? (170 volts). At first moment, power drops. See? Do you see what happens? I increase voltage to 240 volts. Oops. Reduce voltage. And regulator plays back. So in some range of voltages, I increased voltage primary, and system compensates it back. Люблю.
समझ आया? Can you tell me what part is on the screen? Which one?
One second. Be right back. No, I just who is air conditioner.
Okay. 1 hour. Class is over, guys. Class is over. Guys, this university started working. This one. You have no idea.
They're starting, but I think it's not actively working.
Yeah, that's what I'm saying. It's opening, but then
When? Open. Already open.
like it's gonna be in this Elizabeth Hotel, Radisson Hotel on Elizabeth, the bigger one,
Yeah.
the most bigger. It's gonna be inside it, and they'll start working soon.
Yeah, soon. Otherwise,
And we are by 1st of January, we are free on visa for Russia, Indian passport
what?
for Russia. Yeah, free visa on arrival. We just can take bus from this terminal with Indian passport.
We can go to Russia.
Yeah.
There is war.
So war is not in the everywhere. The cities are working as usual, obviously.
Yeah. Moscow.
Yeah, Moscow is like 10, 12 hours. Yeah, it's only 800, 900 kilometers from here. Yeah. Petersburg is also. The biggest one which have a bigger porch, I guess on this one here at Brivivas crossing. Yeah, which have a bigger outdoor porch. Do we need to fill this survey?
It's from Matthew.
Yeah, it's open on front, right? Whenever you open on.
പാസ്പോർട്ട് പോയി അങ്ങനെ ഇവിടെ ഒരു പ്രശ്നം വന്നു കഴിഞ്ഞാൽ നമ്മൾ ബന്ധപ്പെട്ട് കോണ്ടാക്ട് ഇതല്ല ഇപ്പൊ നമുക്കിപ്പോ ഇവിടെ എന്തെങ്കിലും പ്രശ്നം വന്നു പിന്നെ ഇങ്ങനെ ഒരാൾ തല്ലിക്കൊന്നു അല്ല കാര്യം അങ്ങനെ വരുമ്പോ നമ്മളെ ഹെൽപ്പ് ചെയ്യേണ്ട അല്ല ഇത് മുന്നേ പറഞ്ഞു ഇല്ലെങ്കിൽ നമ്മുടെ ഇപ്പൊ ഉള്ളത് ഇവിടെ അടുത്തുള്ളത് സ്വീഡനിൽ അങ്ങോട്ട് പോകണം പാസ്പോർട്ട് പോയിട്ട് പോയായിരുന്നു പാസ്പോർട്ട് പോയി അതിനൊക്കെ അവൻ പോയിന്നാ പറഞ്ഞ കിട്ടി പാസ്പോർട്ട് വേറെ കിട്ടി നമ്പർ ഉണ്ടാവില്ല നമ്മുടെ ഓൾറെഡി ഒരു പാസ്പോർട്ട് ഉണ്ടല്ലോ അവര് വെരിഫിക്കേഷൻ കാര്യങ്ങൾ ചെയ്തിട്ട് അവന്മാർക്ക് ഒരു ഇഷ്യൂ ചെയ്തിട്ടുണ്ടോ നാട്ടിൽ നിന്നോ അല്ലെങ്കിൽ ഇവിടെ നിന്ന് ഇഷ്യൂ ചെയ്തു
Damn. So why I'm interested in this thing? Okay, now it's a toy. It's a demo of closed loop regulator. It's a demo of classical closed loop. Classical system, when you have your control object, you have a regulator, from the object process variable is taken, you have process variable, you have classical set point, and regulator do something to it dealt, or difference between process variable and set point to the zero. Classics of regulation theory. But why it's here? We are not speaking about regulation theory here. This object is here because it's good. It's illustrated. One of the basic of energy supply. What's the basic? You have 110 or 115 kilowatt network. You have your substation. Here should be star, a belt, powering your distribution network. I don't know, it can be 10, 11, 12, name it, 24, 35 kilowatts. Middle voltage distribution network. Here we will have 0.4 kilowatts attachment. This connection point, a lot of this network is, come on, no, I will not run, go to hell. A lot of this network changes. You will see virtual no during the night time. Okay, it varies how deep is air conditioning penetration. And you will see load peaks at morning, very good correlation with school schedule. When children should go to school, okay, everybody wakes up. And you will see good correlation with evening time. Interesting thing, you will see good correlation with football timing. Because everyone switched their TV and so on. Okay, load here variable, you need to compensate this variety. Otherwise, you will see a voltage outside allowable, say areas, allowable margins. You can go down by 5 here. You can go down by 5%, and you can go up 10%. It's your margins for voltage quality. Otherwise, public utilities regulator, SPRK, Sabiedriskās pakalpojumu regulations committee, regulatory commission for public services, will find it. Meaning, what you need to do, compensate this load change. How it's done? This transformer actually has a set of taps at a neutral side, and these taps can be switched. The transformers are equipped with so-called tap changer. Older had like barrel one on the top. Modern one, if you take a look on a large transformer, you can see kind of sectorial opening with usually with brown plastic cover, quite big, like this side. Inside is a sectorial tap changer. They are barrel-like, where it's a sliding contact, rotates, or like piece of pie. Here are taps. Where is my... something similar to this system. Wait one moment, I need... See? Changes. Like this device, much bigger. Because currents, with the help of tap changer, you can change transformation ratio. And this device, voltage controller, or automatic, sometimes called automatic voltage controller. At the bus sits interim transformer. It produces 100 volt signal to voltage controller. And controller changes transformer ratio to keep distribution network bus voltage within limits. It's not 100% precise because it's not a continuous change. It's only can change by a text. It will have that zone, something like 1.25, 1.5, sometimes 1%. This one also has that zone, because winding is discrete. But the tap changer with voltage controller will act exactly the same way my regulator do. And take a look. I decrease voltage. What happens with power? Increases, 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 increases. Tap changer works until it sets voltage back. Power returns to its previous. I increase voltage. What will happen? Down, 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 down. Down, 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 down. Oh, and it's on the same decreased voltage and power. Because a regulator compensates voltage change, power going to load remains constant. We have a transient while tap changer works, but at the end we will go to the same point, to the same place, and this place is determined by set point of control system. That's what we see in a regulated network. Is this thing linear? Is it something familiar from electrotechnics theory? Problem with such kind of network is something different from electrotechnics classics. This network will act with its synthetic characteristic, will act as control system. Logic, how to say, drives it or sets it. We got problem. We facing a problem, but it's called constant volt ampere load. It's just a name. Actually, you see, I can change voltage, but power will remain the same. So we are in problem. We have a network with elements of constant power. Such network is not linear. It can be solved as a classical electrotechnics network. I have problem. What can I try to do? I need some approach. First, power is voltage multiplied by conjugated current for single phase. In case we have three phase, we deal with polyphase network. Three phase network, power will be free voltage conjugated current. And here tradition hits. In such kind of calculus, it's because of tradition. We can use line-to-line voltage or phase voltage. Yeah? Tradition asks to use line-to-line. 110, it's line-to-line. 10 kilowatt network is line-to-line. To be line voltage, I need square root here. So, current will be power with conjugation divided by square root of 3 and by voltage. Why I'm writing this? I want to do a trick. See, I don't have any modeling space outside electrotechnics theory. I need to bring into this space my control system. How can I do it? My idea is use a controlled current source. Who and why?
Неужели там 4 картриджа надо для этого? Нет, 4 цвета.
Да, там 4 цвета. Там красный.
А будет один черный работать? Такое...
Не, он клиновой.
То есть не будет?
Да.
Обалдеть.
Ага. I want to do a trick. What kind of trick? I would like to implement control system as a controlled voltage source. I would like to do a trick. I will use controlled current source, where current is function of some control voltage. Okay? What idea? Actually, I can try to use controlled EMF or controlled resistance. If there is a control system, should be I need to somehow reflect it in my mass model. I would like to create a mass model because I need to perform calculus. Computers work with mass object, mathematical. So I need a mass model of with my control system. This mass model will arrive how? I will derive it from something electrotechnical. Yeah? So I need something from electrotechnics theory, but with control knob. I prefer to use current sources. So my trick will be, I will conduct vector of power in the nodes where generators are connected. I will write the power with the plus sign. On the nodes where load are connected, so generator, load, I will write its power with the minus sign. Power, not current, but power. And in my simple example where powers are constant, I will be able to play with network solution. First, we know what any network can be described with its nodal voltage equation. Yeah? Classical nodal voltage equation mz inverse plus conductivities of base node, voltage of base node, nodal admittance matrix, transpose. I will use this to reflect current, to reflect control system. How? Easy. I will rewrite my equation in this form. D plus y b. If needed, you can use also AMF, but my approach do not require them. They can be used, but at first approach I will not use an AMF. What's here? I is conjugated power of node I divided by square root of 3. It's a diagonal matrix. Here I should be changed from 1 to number of nodes. And this one is 1 divided by conjugation of appropriate node. You see, it's a, here I put a current, like my formula. Current is a conjugated power divided by square root of 3 conjugated voltage. Using this, I got nodal currents. Can the system be solved? At the first moment, when you look at it, it's not a system of linear equation because I have voltage on both sides. Appears what I got system of non-linear equation. Non-linear equation in form of current balance. Very good. It is not solvable by hand. It's not solvable analytically. But I have one more, how to say, rabbit in my head. What a rabbit? Sequential approximation technique or Seudel technique. Yeah? Previously, we solved system of voltages when we solved AC network with the Seudel technique. It was next voltage in the node I can be found as sum where should be changed from 1 to I minus 1 next plus wait 1 second sum where m changed from I plus 1 to number of nodes CIM UM previous plus 1 divided by YII. Here was II plus here sorry, not plus but minus MZ I will be simple BI equals to I minus m I plus y b b. For each I from 1 to number of nodes. Ci minus yi divided by yi. Here, yeah, that's what we used when modeled AC network. I multiple times used this Seudel function. I just copy pasted it multiple times. Now I can reuse it. There is one interesting moment. Physically, how many voltages do I control? One? One. And numerically, how many voltages do I have? I have next voltages and I have previous voltages. Yeah? In this process of sequential approximation, I have both previous and next. So physically, I have only one voltage, real. But numerically, in mass space, I have two voltages, next and previous. I can do evil Knievel jump. I can calculate currents for the next voltages using previous voltages as a control or as an input. Look what I can do. I can modify this. I can modify this process in such forms. Node voltage of node I next can be found as sum where from 1 to I minus 1 Ci next plus sum where m changes from I plus 1 to number of nodes CIM OM previous plus this part is like previous electrotechnics theory. 1 divided by power in node I conjugate divided by square root of 3 voltage I conjugated previous. This will produce current. Current as a function of previous voltage. I have two legs. Closer, closer, closer. So I can calculate something for the next using previous plus this should be done for any I started from 1 and ending from number of nodes. Here I got as a way to solve problem of nonlinear network with incorporation of modified, with upgrade of Seudel technique. And each step I will recalculate currents. I will use my current sources will have control value previous step voltage. No problem with precision. Next. Previous, it's not. All is the same. All the same from classical solution of orthotechnics problem. Key trick is possible. What I did add a more when I created my model. In my model, I substitute real control system which controlled current source. This at numerical stage, I use previous voltage of iterative process to control this current source. Actually, I can put here anything. I can reflect any control system only if I can. The only convenant I should be able to depict it as a current being function of voltage. Here I can write anything. Only I should be able to set this current. If my system has limitations, okay, they will be in if inside. But general I can show or introduce my control system in a form current function of voltage. I need to show solution, yeah? How it's so I have network, something very similar. Network like this, load, something, generation, load. One more trick with such kind of calculus. Usually, in such kind of calculus, we use base node to reflect powerful station performing a voltage control on the high voltage network. High voltage network also needs voltage control. Large power plant, usually it's so-called balancing power plant, only receive additional money for balancing, which keeps voltage and power balance. Power change, it should be better use hydropower plants, they are more suitable for power maneuvering. So one of the power plant or a large system, if we use equivalence, for example, UCTE, whole UCTE will be a base node or slack bus. English terminology here correct is a slack bus. So powerful power plant, keeping voltage and most important power balance. Okay, 1 second, I need to reconnect myself. There. To do so, where's my silver? 1 second, I will open my yesterday work. I already have one. Come on, okay. Wait 1 moment. Sorry. I need to share my screen. Oh, this is fine. It is. Yeah, what I got here. It's a solution code. I tick it to get execution time. Clear, erase everything. Next, I use line length in kilometers to compose resistance vector. Here, it's usually for 110 kilovolts network, resistance of 1 per 1 kilometer will be something 0.2 plus 0.2 active plus 0.4 inductive. 0.2 plus 0.04. Here, for, I don't know, from some line, somewhere near 0.90, 0.21, something like this. Here, you see, I'm conducting resistance vectors simply multiplying line length by resistance of 1 kilometer. In reality, of course, there will be a real data of lines, but not important in this moment. Familiar matrix branch nodes. MS is number of nodes, number of branches. Here, loads and generation. S from Latvian loads, it's load. Load, active, reactive, active, reactive, active, reactive. Here I'm conducting power vector of powers. Loads are going with minus sign, generation with plus sign. Square root of 3, this will be give a bit speed up for my program. See this? I'm forming the diagonal vector of this D matrix. It's a conjugation of power divided by square root of 3. Because I have 3 phase and I need to perform calculus for line voltage. Also, very simple inversion of resistance vector. I can do it because I'm dealing with symmetrical regime, no mutual inductance at all. In symmetrical regime, how to say, erases or deletes or makes omits all mutual inductance. So I throw them out. Okay, nothing to do for human here. This one, it's in computer language is to create computer, please create for me a vector with one column and rows as number of nodes of ones and multiply it for me for base node voltage. But where the idea? See, voltages of such network, I don't think they will be too far from base node voltage. It's a starting point. I will go sequentially towards the real solution. I don't think this solution will be somewhere far from base node voltage. So to increase performance, I will start from base node voltage. Not from zeros, but from base node voltage. So it sets the starting point or U with the 0. I will need transposed M matrix. For what? For nodal admittance matrix. Got nodal admittance matrix. I'm near happy. One more moment. I need, because base node voltage will be something, not 0, but actually set point of base station or balancing station. That I use balancing station. I need a nodal conductivities to the slack bus or base node. I can create it by hand, but why should I? Sum of node or admittance matrix row elements gives me base node conductivity for node I. For this point, so this small part calculates base node conductivity vector. Next step, this step. I need this transfer C matrix for the Seudel technique, as I used before. Simple, very simple operation, 2-4 cycles. Precision, number of steps. Next, I need, how we solve with second iteration? Repeat until precision reached, yeah? What should I repeat? What's wrote on the table? So repeat until precision here. Repeat until precision. Repeat what? For I from 1 to number of nodes. Where is I from number to nodes? Here is my I from 1 to number to nodes. Repeat for each node. For each node do what? Calculate this sum with new voltages. Calculate second sum. Yeah? This is for second sigma. And for square brackets, here are my square brackets. This is I divided by conjugated voltage, and O divided by diagonal element of nodal admittance matrix. Don't forget to calculate precision as a maximum absolute difference between voltage, and go back, repeat until. As a result, I will get Solus height is number of steps, U voltages, absolute values of voltages, currents as we did before by Ohm law, Zarus-Strauss mean branch currents, absolute value of branch current, and here starts something not seen before. Jaudas plūsmas or power flow. What's a power flow? I have network. What's a power flow? If I put a wattmeter in my line, wattmeter will show me PG, power. We are selling, they are buying. Power flow is a flow of energy by line. So, full power on each line will be square root of 3 voltage at node I, branch current at branch J, conjugated. If here should I write M I not 0. If branch J is connected to node I. So if I need to calculate here flows is and I can put a voltmeter, and this will be voltage of I. Yeah? So I need to go through all nodes and all branches and at connection points calculate power flowing by particular line. So jaudas posms, maybe, what I will do, I will save this. Today we have 15. Next, what this? Why should someone perform such kind of calculus? To get voltage, to get currents. Most, how to say, aim or goal of such calculus is to establish economy. I need losses. Loss, on the one hand, I have, what I have? I have problem because there are bosses with their KPIs, and one of the key KPI for network operation, technological losses. Standard threshold is 5%. Above 5%, no more bonuses here. But I will get bonus for effectiveness. So it's a task of optimal power flow. I need to find most profitable way of operation. To do so, I need to know technological losses in my network. What will be, how to say, OPEX of my network? To do so, powerful. Because, see, I can, in reality, I can vary. I can buy energy there or there. I can load this power point or that power point. I can even play with transformer radius. I can play with setup of regulators. This gives me a space. In this space, I need to find most profitable solution. And behind this search, key moment, I need to know transfer expenses, OPEX of network, or I need to know losses. Because it's 100% possible situation. I have a cheap energy at hydropower there, but transfer capabilities are insufficient, and network losses will eat my profit. Here I calculate net losses. For net losses I need what? I need voltage drop on each branch, multiplied by conjugation of current in this branch. ds, it's a difference in power by branch. So it will be triple resistance multiplied by current to get voltage, and multiplied by conjugation of current to get power. I need to account them all, and this will be base. I cannot calculate OPEX, operation expenses, without this data. Here I calculate what's TLK, weight variables coefficient, efficiency ratio. So let's try to start it. I don't know what happens, something should. Okay, what I got? Nodal voltages 103, 14, looks fine. So solution in 30 steps, voltages, currents in kiloamps, power flows, losses by branch, total, this number will say is my KPI, and here total efficiency 96.9, 4.1% losses, it's okay. For example, let's assume I'm a greedy one. Greedy one, I will, what I'll do, I will decrease twice amount of aluminium. Алло. Давай сейчас занятие лучше. Чуть позже. Да. Окей. I have increased twice resistance, meaning what I twice decreased cross section of wires. Look what happens. Oops. 93.99, 94, 6%. Will I get my bonds? No. This version. On the opposite side, I would like to invest more. Double wire. Oh, 1.5% loss, very economic. But capex doubled. No. You know, it's a tricky thing to calculate when you prepare data for new build. You will find an interesting thing. Construction expenses of power line are in small depends of the wire cross section. Amount of work needed to erect towers in quite wide ranges do not depend on wire cross section. It's one thing, and second, in your capex, giant part of your capex will be land for construction. Land price is not dependent on wire cross section. So it's quite a meticulous job to perform a technical background analysis for line construction. But it can be done. This thing you need it. See, you need there is an optimum. If you take capex, construction expenses, take a central bank interest rate, you can predict capex for future. Then, assuming inflation following central bank interest rate, for example 5% per year, and assuming load, you can calculate operational expenses, losses. When you compare them, you will see set of charts like this which define extrema. This extrema gives you best best wire cross section for your line. But you need this tool to calculate losses, because you have two things to balance: construction expenses and cost of ownership. OPEX, operational expense. This thing can help you, how to say, to get bonus. If you're able to calculate network losses, it's a how to say, most labor consuming part in optimal construction or the optimal development solution search. Okay, what else? Nothing here actually everything is very simple. Effectiveness, efficiency should be written. What I want to say, I forgot. The only solution to this very unpleasant problem, where what I'm doing, I'm deriving electrotechnics theory model from the network, and then I solve this model with second level numerical model. Here, key trick is to reflect control system as a controlled current source. And done. Very simple. Very, very simple process. Gain voltages. What's this? Voltages. Strange thing. Okay, maybe some questions? No. Questions?
No.
No. That's mean what can I do?